everyone, welcome to my channel. My name is Rachel and I'm going to be talking about sales forecasting in this video. So sales forecasting is a valuable application of the time series analysis, and the goal is to predict future sales by analyzing the historical time series data generated from a business. In this video, I'm going to be sharing with you a guide to performing sales forecasting using Python. I'll take you through the process of analyzing historical data and making predictions for informed business decisions. So if you want to work along with me, you will see the data sets in the description of this video. I put the link in the description so you can just you can use the link to download the dataset so you can work along with me. And I've already written the code here so that I can save a lot of time. So let's get right into it. The first thing I did is to import the libraries and dataset. So these are the libraries I'm going to be using here, and we'll see how they're going to come into play as we go on in this video. So I'm going to be using pandas for data manipulation. I'm going to be using the matplotlib for data visualization. I'm going to be using the stat models, the API for modeling and forecasting. I'm going to be using the autocorrelation plot to visualize the autocorrelation. So the autocorrelation is used to identify seasonality and lag effect in the data. And I'm going to be using the plot ACF to also for correlation, and I imported the SARIMA, which I'm going to be using to fit the SARIMA model. And I also imported PMD Harima, which would allow me to automatically generate the parameters which I'm going to be using for my SARIMA model. And lastly, I imported the SkyPy, which I'm going to be using to test for stationarity. Okay, so I'm going to run the libraries. Okay, that has been done. And the data set I'm going to be using, I already imported it and named it DF. So let us view the data. Okay, so the data set has 4 columns, which are the date, store, item, and sales. And the sales are from 2013 to 2017. So let's go straight into data cleaning and pre-processing. So the first thing I want to do here is to remove the unwanted columns. So then I said columns equals to the store, comma item. So store and item are the columns I do not need in this analysis. I only need the date and the sales column. So I'm going to say df.drop columns, which I already stated here, and axis equals 1 in place equals true. I'm going to be running that. Okay, so I want to check the information of my data set. So this is showing me the columns, the count, and then the data type. So we can see that there are no null values here. However, the date column is object, that is the data type is object, and it's supposed to be date time. So I need to convert that from object to date time, which is the next thing I'm going to be doing. So here I said df.date equals df.date.hasType into brackets date time. So I'm just going to run this. So this would convert the date from object to date time. Next I'm going to do is to then group the sales into months. So I want to group this into monthly sales so I can see the monthly sales. Okay, and if I check my data frame now, you see that I already gotten rid of the other columns I'm not going to be needing, and the date column now is in it has been grouped into monthly sales. So then I want to convert this into timestamp. Okay, so I'm going to pass in my df.date equals df.date.dt.to timestamp. That would convert the date column into timestamp. So the next thing I want to do is to check my data. Okay, you can see now that this has converted it to timestamp, I mean. Okay, so now to sum up the sales into to sum up the sales in each of the months, so I'm going to be using the group by. Group by would help me to group the sales in each of the months. Okay, so the next thing I want to do here is data visualization. Okay, and this is where the matplotlib come into play. So if I run this, so this is showing me the monthly sales from 2013 to 2017. So we can see here that there's a seasonality in the data, and it's showing that there's a fluctuation in sales on a monthly basis. So you see that sales goes up at the beginning of the year, and once it comes to like the peak towards the end of the year, then it starts to decline. So to better understand this data, we are going to be doing some exploratory data analysis. So the EDA would help us to understand better the patterns, the trends, and the characteristics of the data. So the first thing I'm going to be doing is the time series decomposition. This would help me to break the data set down into different components, which are basically the level, trend, seasonality, and noise or residual. So I'm going to be using the seasonal decompose method to do that. So I'm just going to run this. Okay, just to mention that I'm using the additive decomposition model here because the increasing and decreasing pattern of the time series are similar throughout the series. So alternatively, you can see that here, right? So alternatively is to use the multiplicative model. So you can use that if the seasonal component varies in magnitude over time. So what I did basically is to visually inspect the data and assess whether the seasonal variation appears to have a consistent magnitude. If it has a consistent magnitude, then I'm going to use the additive model. If there's a variation in the proportion to the trend or the level of data, then I'm going to be using a multiplicative model. If you're not really sure of what model to use, you can compare the performance of both model, or you will use some statistical metrics to choose the one that better fits the forecasting accuracy for your data set. Okay, so from this chart here, you can see that there's a linear, or say an upward trend in our sales, and you can see that there's a seasonality in the sales, just like I mentioned earlier, that it shows that throughout the year we're seeing an increase in sales, and when it comes to mid-year it starts to drop. So we can see that has been occurring in each of the years. So see that in 2013, 14, 15, 16, and 17. So we can say that there's been a kind of seasonality in our data set. Okay, so the next analysis I'm going to be doing is the autocorrelation. So autocorrelation is used to measure the correlation between a time series and its lagged value. So here's how it works. If I run this autocorrelation underscore plot into brackets your data set, okay, you see that from this graph it confirms that there's a seasonality in the data, and we can see the sinusoidal wave that's seen every 13 to 15 lag. So you can see starting from 0, so this stops around here. We can see 13 or 15 lag, so which is the same as here too. It's like stopping at every 13 to 15 lag. So we can see that there's obviously seasonality in the data. So another analysis we can do is to plot the autocorrelation function. Okay, that is where we use the plot ACF for. And if I run this, okay, so from the autocorrelation function, that's the ACF plot, we can see that there's a strong correlation at between lag 0 and 12. Yes, between lag 0 and 12, we can see that here. So this means that there is monthly seasonality in our data set. Okay, so you can also check for the partial autocorrelation function. Let us run this. Okay, so this is also showing that there is a strong seasonality in our data, which could be monthly. So the next step will be to check the stationarity of the data. Here we already know the patterns, the trend, the cycle, and the seasonality. So we need to check if the series is stationary or not. And a stationary series is the one which the properties, which are the mean, the variance, the covariance, do not vary with time. Okay, so that means they are constant, and that is where the Dickey-Fuller test comes to play. It is also called ADF test. ADF test is also used for model selection. In any time series analysis, there are actually different models which you can use to predict your future sales or revenue or weather or whatever. So for example, you can use the autoregressive integrated moving average, which is the SARIMA model. So that is commonly used for the stationary series, while you can use the seasonal autoregression integrated moving average, which is SARIMA, that is suitable for a non-stationary series. So the ADF test will assist us to select the appropriate model which will be used for the prediction of our sales. Okay, so let us run the ADF test. Okay, so yeah, the null hypothesis is that the time series possesses a unique rule, that is, it is non-stationary. So if the calculated p-value is less than the chosen significant level, so in this case I'm going to be using 0.05 as the significant level, then the null hypothesis of the non-stationarity is rejected, which is indicating that the time series is likely stationary. So according to the ADF test, we can see that the p-value is greater than 0.05. So our p-value is 7.0264, which is greater than the significant level that we've chosen. So H whole cannot be rejected. So that is, we have to accept it. It means that the data has a unit root and the series is not stationary. Okay, so it means that there is seasonality in our series and the seasonal ARIMA would be appropriate. So you can see what I wrote here, that the p-value is greater than 0.05, meaning that the data is stationary and SARIMA is appropriate for this model. The main one of the difference between the ARIMA and SARIMA model is that ARIMA model assume that the data is stationary and there are no seasonality in the data, while the SARIMA model makes provision for the stationarity or the seasonality in the data. So in this case, that it has been proven that the data is not stationary, then SARIMA model is appropriate for the prediction. So SARIMA is the seasonal autoregression integrated moving average. Okay, so next step is to then build our SARIMA model. We're going to be, first we need to do this to build the SARIMA model. In building the SARIMA model, we need to get our parameters, which are the P, D, and Q. So we're going to be using the Autoregressive and the PMD SARIMA library, which will help us to automatically generate those parameters. So it will search for the most optimum model building within a certain range. So if I run this, it's going to run and give us what is the best fit for our PDQ, which will be used in fitting the model. Okay, you can see here that the best model is 0, 2, 1, 2, and 12. Okay, so next thing I'm going to be doing is to train my data. Okay, so here I have separated the last 12 months as the test data and the remaining has the training data. Okay, and the next thing I'm going to be doing is to fit the SARIMA model. Okay. So don't forget that we already got in our parameters here. So my order is 010, which I got from here and I put in here, and the seasonal order would be these 212 and 12, 212 and 12. And after fitting the model, I went ahead to then make my predictions. So I did this by using the predict function, and this gave me my predicted value from 2013 to 2017. So this step, you might skip this step, it's not all that necessary because we are still going to test out the model. So I just want to visualize this to see how my model is doing. And if you see this visually, you can see that the model is not doing so bad, but there's also a way to evaluate these rather than just visualizing your data. Okay, so moving on would be to test the model. Just like I said, that you might decide to skip this prediction part, just move on to your test data after you already fitting the model into the data. Okay, so my test model, so I also went in with the SARIMAX and putting the order and the seasonal order into the data. So this is simply fitting the test data, but instead of fitting here, I was fitting the old data frame. Okay, no, supposed to, how am I fitting the whole data frame here? Supposed to fit the train data actually. Where is this TF2? It should be train data. Okay, yes, this is it. My test data into the model, so the same order and the same seasonal order, just that I'm changing this from train data into test data, and I'm going to be making the prediction. Okay, so I'm going to run this, and here I'm going to be visualizing my test data against the predicted data. This is predicted one. Yes, that's correct. Okay, so this is how, this is the actual is in blue while the predicted is in orange, and well, you can see it's not doing so bad. Just like I said, that we're still going to evaluate this model. So next I'm going to do is to then fit the, I'm going to be doing is to then predict my sales for the next 3 years. Okay, so I'm going to be using the model.fit function for this. So I'm going to pass in my test data, and I'm going to be passing the number of period, which is 36 months for 3 years. And if I run that, it's giving me the predictions from 2018 to 2020. And next thing I want to do is to visualize that. So I'm plotting the data frame against the predicted value for the next 3 years, and this is what I have here. So I have data for 2019, 2020, and 2021. So what I did here was just to concatenate the predicted one, which is what I have here from the test data, and concatenate it with the new predicted value that I have for the next 3 years. And what I did here was just to visualize that, and this is what it is showing. So the next thing to do is then to evaluate my model to see if the model is actually performing well. So this will help me to know if my analyses are correct or my predictions are correct. So I'll be sharing this with you in my next video. Thanks for watching. Kindly